Hi, biology students. I wanted to take a few minutes to walk you through the disease simulation activity because it has a couple of different parts and it's a pretty important part of biology. In fact, whole fields of study, epidemiology and virology, are dedicated to looking at how diseases spread, how a contagion spreads within a population. And that population can be animal, it can be plants, it can be people. Um, Disease is caused by three types of pathogens: virus, such as the cold, um, a bacteria, or potentially a fungal pathogen. So we're going to actually use a simulation here. There's the website here and also the link here. And we're going to report our findings from the simulation using these data tables. This one tends to work for PC users, this bottom one better for Mac. So your data table looks a little like this. And we're actually going to do 3 different lessons, and each lesson has 2 different steps. So I've got lesson 1, step 1 and 2, lesson with some notes down here, 2, step 1 and 2, and 3, step 1 and 2. And each of these have questions, just a couple of short questions. Okay, going to the simulation, we're using the website called The Habitable Planet. And this one's pretty interesting. The overview is a good place to start, so click on overview, and it's going to talk a little bit about how diseases spread, why we care, the fact that diseases can be very contagious, so meaning the transmission rate is very, very high. It can pass from me to you very easily. And things we also look at are kind of how deadly they are. So we become concerned when very potentially deadly and dangerous diseases are highly contagious. And we look at a lot of different things like demographics, such as the size of a population, how closely, so density, how closely those people live. It's easier to spread diseases. And of course, who's immune? So starting with the first lesson over here, the lessons, step 1, the virgin field, this idea that when a very new disease arrives at a place, there's no natural immunity. And if you've been in my history classes, you know that with colonization and imperialism, we see disease killing off a lot of people because they have no natural immunity to it. So step 1 has you looking at a simulation. I'm going to open the simulation here, where nobody has any kind of immunity. Let's see if I can get myself out of the way there. Get out of the way, Heather. I'll go over here for a while. So we have no immunity. So all of these people are at risk, and these 2 folks are contagious. And we're going to look at a particular disease. We're going to look at just a cold with a K. And this disease, let's look at the details. This disease lasts about 5 days, so your contagious period is about 5 days, and the transmission rate is 10. We're going to run this disease for a period of days. Let's do 100 days. I think all the simulations run for 100 days. So in my data table, I'm going to record some stuff. For lesson 1, I'm going to put the population number down. In this case, it's 600, but I can play with that if I want. I'm going to run 3 different simulations, and you can change any of this data in between the simulations. So if I can make a lot more people, this is like 900 people, I can make it lower. Let's just stick with 200 or 600 for now. So in my data table, I've got 600 people, and there were only 2 sick people to begin with, right? Who's contagious? Oh, 3, my bad. So 3 folks are sick. Right now, there's no sick days. That's how we're measuring. We're measuring how this isn't a deadly disease. And we can tell that here there's no death rate. So we're going to predict how bad this, or measure, I should say, quantify how bad this disease is based on the number of sick days. So I don't know if everybody's sick for 5 days. I know I've got at least 15 sick days here between these 2 people. So I don't know. I'll do my prediction like, I don't know, maybe half the amount. Let's make it 300 sick days. Okay. And at the end, how many people are still contagious? I don't know. I'll just put 3. And the contagion rate I know is 10%. So let's run the disease. Let's see what happens. All right, so this folks, their neighbors are getting sick. Oh, but look, now they're turning blue. When they turn blue, they're actually becoming immune to the disease. So I'm seeing a couple things. I'm seeing my number of people who have had the disease and then are not sick anymore, but they're now immune to it go up. That's very typical in a virus. Think about chickenpox, for example. And I'm also seeing my at-risk number of people go down because since they're immune, they're not at risk. That means they've had it, they can't get it. And fortunately, nobody died. Yay. But whoa, look at the number of sick days, right? So my data table, I'm going to write this information down. And so I can say my population numbers stayed the same. No one died. Number of people who are sick afterwards looks like only 2. So put that down. And number of sick days, number of sick days was a lot more than I thought. Dang, 1686. And there's only 2 people contagious afterwards in the contagion rate. By the way, contagion or transmission rate, we can look at in a real population. We look at the number of the population, how many people are infected at the initial measurement, and it's over a period of time. And I believe with most diseases, they look at months. We're looking at a period of 100 days. Anyway, I'm going to run different simulations, and I can play around with stuff, right? My variables can be population size. It's going to spit out at you different number of contagious people to begin with. You can imagine if this number is higher, maybe, that you might see a greater number of sick days over here. How many are left? And the contagion rate should be there. So you can play around with those factors, and that might also, you can also play around with how contagious it is, so how transmittable, I should say, it is. So what if we, I don't know, let's make it really, really virulent, right? Really contagious. Let's just see what happens. Oh, all right. Well, nobody died. That's good. Always a sign of a good biology lab. But you can also play around with different diseases. So going through the different steps. So step 2, you'll be answering some questions and running the simulation for the data table. Part 2, lesson 2, we're going to look at, let's look at our data table. Lesson 2, we're actually going to look at population size. And lesson 3, we're going to look at number of people who are immunized and how that impacts the folks that are affected. So you are messing around with different controls, or sorry, different variables. And the questions at each of these at the bottom here. So lesson number step number 2, what can be done to prevent the spread of disease and low population density, go in those boxes. So hopefully you found that helpful.